We're in section 8.5. And so far everything that we've done in this chapter, we've been working with right triangles. We talked about the Pythagorean theorem. Pythagorean theorem works for right triangles. We talked about our special right triangles. That was for right triangles. We did our trigonometry, SOHCAHTOA. That was for right triangles. The law of sines gives us a way for working with triangles that are not right triangles. So let's say what the law of sines is, and then we'll talk about where it comes from, and then we're just going to do a couple of examples. The law of sines. Let's draw a picture here, and we don't have to have a right triangle here. This works for any triangle. And I'm going to call this triangle A, B, and C. And remember, we talked about how we label the triangles, that the angles are labeled with capital letters, and we label the side across from it with small letters. So that would be side A, this would be side B, and this would be side C. So the law of sines tells us, for any triangle, and we're going to call it triangle ABC. And so A, B, and C are angles, and the sides are small a, small b, and small c. We get this nice set of proportions. The sine of angle A over side A equals the sine of angle B over side B, and that also equals the sine of angle C over side C. And I can flip these over. I can do the reciprocal of each of these. I can write it either way. So I'm going to say or A over sine A equals B over sine B, and that equals C over sine C. So we get this set of proportions that we can work with for these triangles, for these types of triangles, for any triangle. Notice that we're matching up the sine of the angle with the side across from it. Sine A, sine B, side B, and sine of C, and side C. So we're making a fraction of the sine of the angle and the side opposite. And just really quickly, where the law of sines comes from. It looks like it's tricky, it looks complicated. It's really easy. I'm just going to kind of give you an idea of what we're going to do here. So if this is my triangle ABC, and this is side C, side B, and side A, what we're going to do is draw in an altitude. And the altitude of the triangle makes a 90-degree angle with that side. And that's where we find the height of the triangle. Well, if I know the angle A and I know side C, I can find the height of the triangle using trigonometry. I have the opposite side and the hypotenuse of this triangle. So I can use the sine of angle A to find the height of this triangle. But I can go to this triangle as well, and I have the opposite side of this triangle, the height and the hypotenuse. So I can use this triangle on the right to find the height of the triangle. Well, the heights are the same, so I set them equal to each other. And that's where these equations come from. I find the height using two different triangles. I split this into two different triangles, find the height with each one, and set those equal to each other. And that's where all of these proportions come from. And I could draw the height from a different vertex, and then I get the other equations. So the law of sines comes from finding the height of this triangle using trigonometry to find the height of the triangle. That's why it works. So like I've said before, in geometry we like to turn problems into triangle problems, and we also like to turn triangle problems into right triangle problems, because that lets us use a Pythagorean theorem, that lets us use SOHCAHTOA. That's what we did for law of sines. So questions on what law of sines is telling us? So really what we're doing is this is opening up some possibilities for working with different kinds of triangles. We're going to use law of sines, and I'm gonna switch the page here. So what we do with the law of sines is called solving triangles. And when we say solve the triangle, we're just finding the missing pieces. So we're finding sides and angles of our triangle. And we're going to use law of sines for three different kinds of triangles. We're going to use law of sines for angle-side-angle triangles, and angle-angle-side triangles, mostly. And for both of these, we know two angles and a side. So when we know two angles and a side, we can use law of sines. We can also use law of sines for side-side angle triangles. But this one, just make a note that we're not going to do much with where we have to be careful with this, but for side-side angle triangles we have to be more careful. And when you talk about law of sines in Algebra 2, and you go on to pre-calc and talk about law of sines there, the side-side angle triangle, you end up doing some more work with side-side angle triangles. Because if we remember, we said that we can't show that two triangles are congruent using a side-side angle theorem or a side-side angle postulate. It doesn't work. So that's why we have to be more careful. So we're going to use law of sines to solve triangles for these kinds of triangles. Angle-side-angle, two angles and a side, angle-angle-side, two angles and a side, and sometimes side-side angle. So what I want to do is just go through a couple of examples of solving for missing parts of triangles using law of sines. So, any questions so far? When we can use law of sines is pretty nice. It's pretty easy to use, and it's not complicated to set up. All right. So let's take a look at an example. So here's our triangle for this example. So I'm going to call this A, C, B, 25 degrees, 70 degrees, and I'm going to say side A equals 3. And we want to find measure of angle C. We want side B and side C. For this triangle. Well, the first thing I'm going to do here is I look at it and I say, okay, I know two angles and a side. I have an angle-angle side triangle. So this is angle-angle side, and we're going to use law of sines. So what I'm going to do with the law of sines is I'm going to use the angle and the side across from it to make a fraction. And I'm going to use this angle and the side across from it to make another fraction to set up my law of sines. But before we set up law of sines, let's solve the easiest problem first. How do we find measure of angle C? Add these two together and then subtract from 180. Because all the angles in the triangle have to add up to 180. So we can find angle C really easily. So measure of angle C, before we even do law of sines, is 180 minus 25 minus 70. And what do we get? 85 degrees. Are we good? Everybody see how we did that? All right, so now let's set up law of sines for these things that I've circled in colors here. So I'm going to say, since I'm looking for a side, I'm going to put that on the top of my fraction. I'm going to say b over the sine of 70 equals 3 over the sine of 25. And let me just circle these. This is my red things that I set up, and these are my green. So I set up a fraction with the angle and the side across from it. And now we know how to solve these types of things. What do I do to solve this? How do I get b by itself? Multiply. Sine 70 is dividing, so I multiply. So I'm going to multiply both sides by sine of 70 degrees. Just like we've done in SOHCAHTOA. Multiply this side by the sine of 70 degrees. And those go away. And I can say b equals 3 sine 70 degrees over sine of 25 degrees. Now, just like we did when we were doing SOHCAHTOA, I could plug sine 70 into my calculator and turn that into a decimal. I could plug sine 25 degrees into my calculator, turn that into a decimal. If you do that in the middle of the problem, make sure you keep 4 decimal places when you for these numbers. But most of us, because the calculators that we're using are nice, we can type our answer in just like this. So let me get the calculator here, and I'll show you how we type this in into the calculator. So let's see. So that one. It'll take just a second to fire up. And we need to, on these kinds of problems, we need to be a little careful with our parentheses when we put them in our calculator. Mm-hmm.
So when you got down to b equals 3 times sine 25
The other way around. 3 sine 70 over sine 25?
yeah.
Okay. Are you good?
Yeah.
All right. So let me clear that out. So I'm going to type it in my calculator. So I'm going to do 3 sine 70. And I'm going to close that parentheses, because otherwise it's dividing, it'll divide everything before it takes a sign of that number. Divided by the sine of 25. And I'll close that parentheses off also. Hit enter, and I get 6.67. So that's telling me that side B, is about 6.7 units long. So B equals 6.7, about. So we found that. This is 6.7. We figured out, and I'm going to write that, and we figured out that angle C was 85 degrees. Found that out as we did the problem. So now to find side C, I'm going to set up the law of sines again. So I'm going to make a fraction with the angle and the side across from it. and I'm going to say C over sine 85 degrees equals, and I can use this, either one of these again, so let's use this one again, 3 over sine 25. So that is my red one that I did here, and now I have a fraction for the blue, the angle on the side across from it. I'm going to solve this the same way, multiply both sides by the sine of 85 degrees. So I get C equals 3 sine 85 degrees over sine 25 degrees. I did the same steps that I did here. Multiply both sides by sine of 85 degrees. And I can plug this into my calculator exactly the same way. So let's do that. Clear that out. 3 times the sine of 85. I'm going to close that parentheses. Divided by the sine of, what are we dividing by this time? 25? Yep. Close that parentheses. Hit enter. And that tells me that B is about 7.1 units. C. Sorry. C is about 7.1. We found B before. So I go back and I say C is about 7.1. And we have solved the triangle. We found all the missing pieces. So we use the law of sines. We set up a fraction with the angle and the side across from it. Set up another fraction, angle, side across from it, set them equal to each other. And then we just solved that proportion. And again, I could go into my calculator, I could find the sine of 85 degrees and write that decimal down here. I could find the sine of 25 degrees, write that decimal number down here. Make sure you keep 4 decimal places as you're doing your arithmetic. Otherwise your answer, in these kinds of problems, your answer can turn out to be way, way off if you don't keep 4 decimal places. All right, questions there? Anything I need to add there, Ms. Linda, anything? Okay. All right. Let's take a look at one more example. This time we're going to use law of sines to find an angle. So we can use law of sines to find angles as well as sides. So I want to show an example of finding an angle. So here's our triangle for this one. I'm going to call this triangle X, Y, and Z. So this would be side Z, this would be side X, and we're saying side X is 25, and side Y is 30. And for this problem, we want to find measure of angle X. So we're looking for angle X. And we know that this angle is 45 degrees. So we're looking at 2 angles and a side. So we have angle, angle, side. So we can use law of sines. So this is an angle, angle, side problem. We're going to use law of sines. And we're going to set up a fraction with the angle and the side across from it. And we'll use this angle and the side across from it. And we're going to set up the law of sines using those two. Now this time, since I'm solving for an angle, I'm going to put the sines of my angles on the tops of my fractions. So I'm going to say the sine of x over the side across from it, over 25, equals the sine of 45 over the side across from it. So I've got my red pieces of the triangle in a fraction there. and then I have my blue pieces of the triangle in a fraction there. So to solve this, I want to get the sine of x by itself. I'm trying to find angle x. So I multiply both sides by 25. Those cancel. 25 divided by 25 is 1. So I get sine x equals sine of 45 degrees times 25 divided by 30. Now, since we're looking for an angle, what do we need to use? We need to use an inverse. Use inverse sine to find the angle. Anytime we're finding an angle, we have to use an inverse. So what I'm going to do for this one is I'm going to plug this into my calculator and get a decimal for this first. And then we'll find the inverse sine of that. So sine of x equals, and I'm going to plug this into my calculator just like I've written it, sine of 45, and I need to close that parentheses. Otherwise, your calculator is going to do the sine of 45 times 25. So sine of 45 times 25. Make sure you close that parentheses. And then I'm going to divide that by 30. Enter. And I get 0.5893. I'm going to keep 4 decimal places. 0.5893. So sine of x equals 0.5893. And now we need to use an inverse. X equals the inverse sine of 0.5893. Go back to my calculator. And your calculator do something nice if you've done this as an intermediate step. I'm going to do second inverse sine of second of the answer. So it holds the last answer. And I get 36.1. And I could also do the inverse sine. I could just plug it in. Inverse sine of 0.5893 is what we wrote down. And I get 36.1. So we go back here, and x equals 36.1 degrees. So we did the same, went through the same process, set up, used the law of sines, set up a fraction with the angle and the side across from it, angle and side across from it, set those two equal to each other, and solve for the part we need. This time, since we were looking for an angle, we had to use the inverse to find our angle. All right, questions on that example? Now, when you calculate, or with the answers that you're getting when I read off the homework questions, you're sure you're entering into your calculator right and you're getting different answers, check with Ms. Lindgren and I, so we can make sure that you're entering it in your calculator correctly, make sure your calculator's in degree mode, that kind of thing, so you're getting the right answers when you do these things. If you plug them in and you calculate them right, you should be getting the exact same numbers that I get up here. And I've had people that are using their phones as calculators, and they get different answers with the phones than with their calculator. So if that's happening, you need to check to make sure that you're doing the right thing using both your phone and your calculator. All right, so law of sines, pretty easy. Set up these fractions and solve for the part that you need. Not too complicated. Questions? Okay. Our homework.